These are your notes for Unit 6, Day 1 of Algebra 1. If you would like to see your warm-up, the review question, or any homework questions we covered in class today, just look at the finished notes. Today, you guys are going to be able to evaluate exponential expressions using all the different rules of exponents, including the product rule, power rule, quotient rule, what zero is as an exponent, and how to deal with negative exponents. So let's just review exponential expressions. So why don't you take a minute and see if you guys can evaluate the following 6 problems. So go ahead and pause the video and see if you guys can evaluate these. All right, 5 to the 4th, if you were to expand it, it means you're going to multiply 5 4 times. So 5 times 5 times 5 times 5. And remember, 5 is called the base. That's the number that's getting multiplied. And 4 is called the exponent. It's telling you how many times to multiply 5. And so if you wanted to, you could do it in steps. You could do 5 times 5 and 5 times 5. So this could become 25 times 25, which is 625. Negative 2 to the 4th, remember on these you need to be careful. If the base is not in parentheses, you need to follow order of operations. So this means the opposite of 2 to the 4th. So you're going to do 2 to the 4th first, and then you're going to do the opposite of that. So this means the opposite of 2 to the 4th. So we're going to do 2 to the 4th first, and then do the opposite of it. So it'll be negative, and then it'll be 2 times 2 times 2 times 2. And 2 times 2 is 4, and 2 times 2 is 4, and 4 times 4 is 16. So this is going to be the opposite of 16, or negative 16. 0.3 to the 3rd means 0.3 times 0.3 times 0.3. And remember, when you're dealing with exponents, you can multiply them like their normal numbers. So 3 times 3 times 3 is 27, but you have 3 decimal places, so we need to move the decimal over 3 times. So this is going to end up being 0.027. Negative 2 to the 4th. Now, since the negative 2 is in parentheses, that means that negative 2 is the base. So we're going to multiply negative 2 4 times. So it'll be negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4. And positive 4 times positive 4 is 16. Fractions work the same way. So 3/4 raised to the 3rd power would be 3/4 times 3/4 times 3/4. And remember, when you're multiplying fractions, you multiply straight across the numerators and you multiply straight across the denominators. So 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So this is going to be 27 over 64. And then the next one, 4 times 5 squared. Remember, order of operations says you do anything with parentheses. There's no parentheses. Then you do perform operations that have exponents. So we're going to do 5 squared first. So this is going to be 4 times 5 squared is 25. And now 4 times 25 is 100. All right. What if we want to evaluate each expression when they have exponents in it? So again, go ahead and see if you guys can do these problems. So pause the video and try 1, 2, and 3. All right, so if we're going to plug in, remember when we plug in, I always recommend putting what you're substituting or plugging in parentheses. So this is going to be negative 3 times 2 to the 4th power. And now order of operations says to complete exponents first. And we just did 2 to the 4th, that's 16. So this is going to be negative 3 times 16, which is negative 48. On our next one, 32 over x to the 3rd. This would be 32 divided by negative 4 to the 3rd power. Negative 4 to the 3rd power would be negative 4 times negative 4 times negative 4, which is negative 64. So this is going to be 32 over negative 64. And if you reduce this, you would get negative 1/2. X to the 3rd times y squared, when x is negative 1 and y is 6. So we're going to take negative 1 and plug it in for x, and then times y squared. That would be 6 squared. Negative 1 times negative 1 times negative 1 is negative 1. 6 squared is 36. So this is going to be negative 1 times 36, which is going to be negative 36. All right. So let's talk about different rules for exponents. One is the product rule. So product means the answer when you multiply. So let's say we want to multiply 2 expressions together. that have exponents on them. You need the same base in order to use the product rule. So as long as the two expressions have the same base, you can use the product rule. So let's say, for instance, we had like 3 to the third times 3 to the fifth. When in doubt, you can expand these two expressions out to see what the rule is. So 3 to the third means 3 times 3 times 3. So it's 3 3 times. And 3 to the fifth means 3 times 3 times 3 times 3 times 3. And you're multiplying those two expressions. Well, now you can just take the end result and write it as an exponential expression. So how many 3's do we have? Well, we have 3 to the third and 3 to the fifth. So altogether, we have 8 3's being multiplied. So this is going to be 3 to the 8th. Now, if you look at the original problem, which was 3 to the third times 3 to the fifth, what can you do with those exponents to get 3 to the 8th? You add them. So the product rule for exponents says if you have two expressions that have the same base and you're multiplying those expressions, you can add their exponents to get the final result. So this is the same thing as 3 to the third plus 5, or 3 to the 8th. So the product rule says that if you have two expressions and they have the same base, like a to the b times a to the c. So notice they're both base a. The rule is you can add their exponents. This would be a to the b plus c. And if the exponents are variables, like the ones in that example are, that's okay. You just show that you're adding the two exponents together. So again, the product rule for exponents says if you have two exponential expressions and they have the same base, and you're multiplying those two expressions, you can add the exponents to simplify it. So in number 1, we have 4 to the fifth times 4 to the third. Notice they're both base 4, so we can add their exponents. This would be 4 to the 5 plus 3. So the final answer would be 4 to the 8th. And again, if you needed to, you could expand it out. It would be 4 to the fifth would be 4 times 4 times 4 times 4 times 4. And 4 to the third would be 4 times 4 times 4. If you combined all those 4 together, you would have 4 to the 8th, or 8 4's being multiplied. So 7 to the second times 7 to the fourth, 7 by itself has an exponent of 1. So this would be 7 to the second times 7 to the first times 7 to the fourth. And again, you can add those exponents. So 7 to the second plus 1 plus 4. And altogether, you would have 7 to the seventh being multiplied. Or if, again, you could expand this out. This would be 7 times 7. This would be 7. And this would be 7 times 7 times 7 times 7. And so how many 7's are being multiplied? 1, 2, 3, 4, 5, 6, 7. So that would be 7 to the 7th power. Number 3, y to the 5th times y to the 9th times y. Again, all of them have the same base. They're all base y. So if you add all the exponents, 5 plus 9 plus 1 would be y to the 15th. Negative 2/3 to the 6th times negative 2/3 to the 5th. Again, they're both the same base. The base is negative 2/3. And then you have raised to the 6th power and raised to the 5th power. So all together, you're multiplying negative 2/3 11 times. So it'll be negative 2/3 to the 11th power. X to the 7th times z to the 4th times x squared. So remember, the product rule only works if the expressions have the same base. So the only two that I can combine in this expression are x to the 7th and x to the 2nd, which would be x to the 9th. So this is going to be x to the 9th times z to the 4th. The z to the 4th is just going to be multiplied after you're done combining the two terms. On number 6, we have negative 2a to the 4th times 3a to the 10th. Now, if your exponential expressions have numbers in front, so if they have coefficients, the rule is you just get to multiply the two coefficients like normal. So negative 2 times 3 just is a normal multiplication. So this is just going to be negative 6. And then you can deal with the exponential expressions afterwards. So a to the 4th times a to the 10th, they have the same base, so you can add their expressions. So that would be a to the 14th. So your final answer will be negative 6a to the 14th. All right, go ahead and pause the video and see if you guys can try these 5. All right, a times a squared times a to the 3rd. Add the exponents and you would get a to the 6th. 2a squared b times 4ab squared. Again, you could multiply the coefficients, the numbers out in front, and you would get 8. And then you can multiply a squared times a. And if you did that and expanded it, you would get a to the third. And then you could multiply the b's. B squared times b would also be b to the third. So you get 8a to the third, b to the third. On number 3, we have 6x squared times negative 6x to the fifth. Again, you can multiply the coefficients, the numbers in front, and you get negative 18. X to the second times x to the fifth would be x to the seventh. So you get negative 18, x to the seventh. On number 4, b to the third times b to the fourth times b to the seventh times b. If you add the exponents, 3 plus 4 is 7. 7 plus 7 is 14. Plus 1 would be 15. So this is going to be b to the 15th power. On number 5, 3x to the third times 3x to the fourth times negative 3x squared. If you multiply all the coefficients, 3 times negative 3, you get negative 27. And then x to the third times x to the fourth times x squared is x to the ninth. So you get negative 27 x to the ninth. So that is product rule. Power rule for exponents is when you have an exponential expression raised to an exponent. So if you have something like x to the fifth raised to the third power. So you're going to have parentheses and you're going to have an exponent on the outside of the parentheses. That's called the power rule. Well, again, when in doubt, you can write it out. So this means x to the fifth 3 times. So this is x to the fifth times x to the fifth times x to the fifth. So it's actually the product rule in disguise. So if I did x to the fifth times x to the fifth times x to the fifth, I could add those exponents and I would get x to the 15th. But since it's a rule by itself, it's not product rule, it's called power rule. What is the rule? What did I do with the 5 and the 3 to get a final answer of x to the 15th? You multiplied them. So when you have x to the fifth raised to the third power, the rule is you can multiply that exponent times the outside exponent to get your answer. So this would be x to the 5 times 3, and so it's going to be x to the 15th. If there's more than one term on the inside of the parentheses, every single term inside the parentheses would get that outside exponent. It's kind of like the distributive property. So on number 1, x to the fifth raised to the fourth power, again, you could expand it out if you needed to, x to the fifth times x to the fifth times x to the fifth times x to the fifth, and that would be x to the 20th. Or you could just multiply those exponents. 5 times 4 is 20, so you would get x to the 20th. Number 2, a to the fifth raised to the third power. Very similar to that example we did up above. It's just with an a. So this would be a to the 15th. Negative 3 to the fourth raised to the third power. Again, you can multiply those exponents, and this would be negative 3 to the 12th power. AB raised to the fifth power. So again, when in doubt, you could expand it out. So this would be AB times AB times AB times AB times AB. A times A times A times A times A would be a to the fifth. And the same thing, B times B times B times B times B would be b to the fifth. Or, like I said above, if there's multiple terms on the inside, both expressions, or all 3 or all 4 expressions, would get the exponent. So this would be a to the first raised to the fifth power and b to the first raised to the fifth power. And so those would both become a to the fifth and b to the fifth. On number 5, again, 4x to the third y raised to the third power, you could write it out 3 times. 4x to the third y times 4x to the third y times 4x to the third y, which would end up being 64x to the ninth, y to the third, or everybody on the inside would get that 3 multiplied to their exponent. So even the coefficient gets, so this is 4 to the first, x to the third, y to the first. So if you did this, it would become 4 to the third, x to the ninth, y to the third. So everybody gets multiplied by that 3 exponent on the outside. Well, every exponent gets multiplied. And then 4 to the third is 64. So this would be 64x to the ninth, y to the third. All right, number 6, negative 2/3, a to the fourth, b to the second, c, all raised to the fourth power. So everybody's going to get that 4. So every exponent's going to get that 4. So this is going to be negative 2/3 raised to the 4th power. And then remember the rule is you can multiply the exponent. So it'd be a to the 4 times 4, b to the 2 times 4, and c to the 1 times 4. And if you simplified this, negative 2/3 raised to the 4th power would be negative 2/3 times negative 2/3 times negative 2/3 times negative 2/3. The negative 2/3 is in parentheses at the start of the problem, so that's why I get to do it with a negative each time. Negative 2 times negative 2 times negative 2 times negative 2 is 16. 3 times 3 times 3 times 3 is 81. So I get 16 over 81, and then it'll be a to the 16th, b to the 8th, c to the 4th. And that is the power rule for exponents. So why don't you pause the video and try these 5 problems. All right, everybody gets the 3, so go ahead and give everybody the exponent of 3. So this would be 4 to the 3rd, x to the 6th, y to the 3rd. So it would be 64, x to the 6th, y to the 3rd. 2x over 3 to the 3rd, even if it's a fraction, every single term is going to get that exponent of 3, because this would be 2x over 3 times 2x over 3 times 2x over 3 if you expanded it out. So this would be 2 to the 3rd, x to the 3rd over 3 to the 3rd. So it would be 8x to the 3rd over 27 if you multiplied it with the product, with the power rule. All right, negative 3xy to the 4th squared. So again, everybody will get the 2 as an exponent. So this would be negative 3 squared, x squared, y to the 8th. So this would be positive 9, x squared, y to the 8th. 2x to the 3rd, negative 5x squared. Well, order of operations says we need to do exponents first. So we got to do negative 5x squared first. So both of those will get the negative 2. So, or sorry, the 2 is an exponent. So we get 2x to the 3rd. And this would be negative 5 squared and then x squared. So this would be 2x to the 3rd times 25x squared. And now it's just the normal product rule. So 2 times 25 is 50. And then x squared times x to the 3rd. Remember, with product rule, you just get to add the product rule, you just get to add the exponents. X to the 3rd times x to the 2nd would be x to the 5th. So that would be 50x to the 5th. Same thing with the next one. We start with the power rule. So everybody gets the 2. Order of operations says exponents need to go first. So this is going to be 4c squared d to the 8th. And then times, everybody gets the 5 here. So this would be c to the 5th, d to the 5th. And now it's just a normal product rule problem. So it's 4 times 1, because it's 1c to the 5th, d to the 5th. And then add the exponents. So this would be c to the 7th, d to the 13th. So you would get 4c to the 7th, d to the 13th. All right, our next rule is called the quotient rule for exponents. And remember, quotient means divide. So this is when you have a fraction and both of the terms in the numerator and the denominator have the same base, then you can use the quotient rule. So for instance, if I had something like x to the 5th over x to the 3rd, how does the quotient rule work? Well, let's expand these out. This would be x times x times x times x times x in the numerator over x times x times x in the denominator. Well, x divided by x is 1, and x divided by x is 1, and x divided by x is 1, as long as x is not equal to 0. Well, what's left? We have x, 2x's up top, so we have x to the 2nd left in the numerator. So what's the rule? What do I do with these 2 exponents to get to x squared? Well, we have a 5 and a 3, so the rule is if you subtract the exponents with quotient rule, you'll get to your final answers. So x to the 5th over x to the 3rd, you subtract the exponents. So the numerator's exponent minus the denominator's exponent, so 5 minus 3, and you get x squared. So as long as they have the same base, that will work. So let's say we have x to the 9th over x to the 5th. Again, the quotient rule says you can subtract the exponents to simplify, and this would be x to the 4th. 7 to the 6th over 7 to the 5th. this would be 6 minus 5 for the exponent, so that'd be 7 to the first, and 7 to the first is just 7. On number 3, if there's coefficients involved, then just like with the product rule, you would multiply the coefficients. With quotient rule, you're going to divide the coefficients. So we have 6a to the second b to the fifth over 2ab. So we're going to divide the coefficients, and 6 divided by 2 is 3. So we'll have a 3 left in the numerator. A to the second over a, you can subtract their exponents, and you would have a to the first, and then b to the fifth over b. Remember, this is like b to the first, and so 5 minus 1 is 4, so this is going to be b to the fourth. So you have 3ab to the fourth. We have, on number 4, x to the 8th, y to the 9th over x to the 5th, z to the 4th. Well, the only two expressions that get to be simplified are the x's, and x to the 8th over x to the 5th is x to the 3rd. So y to the 9th doesn't simplify with anybody, so he just stays in the numerator. And z to the 4th doesn't simplify with anybody, so it just stays in the denominator. So your final answer is x to the 3rd, y to the 9th over z to the 4th. And that is the quotient rule for exponents. So go ahead and pause the video and try these 5 problems. All right, for the first one, 6 over 2 is 3. And x to the 7th over x to the 4th, if you subtract the exponents, you would get x to the 3rd. So you have 3x to the 3rd. X to the 5th, y to the 6th over xy squared. This is like x to the 1st. So you would get x to the 4th and then y to the 4th when you subtract the exponents using quotient rule. 6 to the 5th over 6 to the 3rd. They're both base of 6, so you can subtract the exponents and you would get 6 squared. And if you wanted to simplify that, you would get 36. Now notice on the next one, we have x to the 4th over x to the 7th. What's going to happen here? Well, let's expand it out. We have x times x times x times x over x times x times x times x times x times x times x. And remember, x divided by x is 1, so 4 x's in the numerator and 4 x's in the denominator are going to end up reducing with each other. When everything reduces out of the numerator, you still have a 1 left over, remember, because like x divided by x is 1, so you have 1 over 1, 1 over 1, 1 over 1. So you have 1 left in the numerator, and what do you have left in the denominator? You have x to the 3rd. So this is the same thing as 1 over x to the 3rd, or what's the rule? We take x to the 4th minus 7. You can subtract the exponents. So you have x to the 4th minus 7, so you have x to the negative 3rd. So what we're going to realize in a second is when you have negative exponents, it's okay. But typically, we'll rewrite it so it has a positive exponent, so we'll throw them in the denominator. And the reason why it works like that is because of the way that we expanded out and reduced. You had 3 x's left in the denominator. All right, let's look at the next one. 9x to the 10th, y to the 3rd over negative x to the 5th, y to the 3rd. Well, 9 over a negative is going to be negative 9. And then x to the 10th over x to the 5th is going to be x to the 5th. Y to the 3rd over y to the 3rd, well, that's going to be 1 because they reduce with each other. Or notice what's going to happen if you subtract their exponents. You get y to the 0. So y to the 0th power is going to end up being 1, which is what we're about to talk about. So 0 as an exponent. How do we get 0 as an exponent? Well, it's like what we just said. If you have something like x to the 3rd over x to the 3rd, the rule is you can subtract the exponents, right? Because you would have x times x times x over x times x times x. And all of the x's, x divided by x, reduces to 1 over 1, 1 over 1, 1 over 1. So this is going to be 1. Or remember the rule with the exponents? You subtract them. So x to the 0th power is going to be 1. So anything to the 0th power is going to be 1 as long as x is not equal to 0. So 0 to the 0th power is not going to give you 1. All right, so simplify each of these expressions using that new knowledge. So anything to the 0th power, so if you have 0 as an exponent, the answer is going to be 1. So 3 to the 0th power is going to be 1. 9xyz to the 0th power, well, if every single term got the 0 power using the power rule, this would just be 1 because everybody would have 0 as an exponent. 4x to the 0th power, remember order of operations says do exponents first, so we're going to do x to the 0th power first, which is going to be 1. So this is going to be 4 times 1 which is going to be 4. So be careful on problems like number 3, because what's 4's exponent? 4's exponent is 1. The 4x is not in parentheses, so the only exponent, the only base that has 0 as an exponent is x. So this is going to be 4 times x to the 0th power. So it'll be 4 times 1, which is 4. Let's look at the next one. So this would be 3 times x to the 0th times y. Well, x to the 0th power is going to be 1. And then over 4xy to the 0th power is going to be 1. So we have 3 times 1 times y over 4 times x times 1. So this is going to be 3y over 4x. So again, anything to the 0th power except for 0 is going to be 1. And now back to negative exponents. So what do we do when an expression has a negative exponent? So how did this happen again? So let's say we have a to the 2nd over a to the 5th. So remember, if you expand this out, you get a times a over a times a times a times a times a. And a divided by a is 1, so you get 1 and 1s. And then you have 3 a's left in the denominator, so you have 1 over a to the 3rd. Or remember, this was originally a quotient rule problem. So the quotient rule says at the start of the problem, if you have a to the 2nd over a to the 5th, you can subtract the exponents. So a to the 2 minus 5, which is a to the negative 3rd. So a to the negative 3rd is the same thing as 1 over a to the 3rd. So if an expression has a negative exponent, it's the same thing as saying 1 over that expression with a positive exponent. And it just works the way that it works because of how things cancel and reduce. So a to the negative 4th is the same thing as 1 over a to the positive 4th. So again, if an expression has a negative exponent, you can rewrite it with that expression in the denominator with a positive exponent. Number 2, if the exponential expression with a negative exponent is in the denominator, then to make it positive, you move it back up to the numerator. So 1 over x to the negative 3rd is the same thing as x to the 3rd. 4y to the negative 5th, again, only y to the negative 5th has the negative exponent. 4 has the exponent of 1. So this is like 4 to the 1st times y to the negative 5th power. So the only term that needs to move down to the denominator to give it a positive exponent is y to the 5th. So this is 4 over y to the 5th. Negative 3 raised to the negative 4th power would be 1 over negative 3 to the positive 4th power. And if you wanted to reduce this or simplify it, it'd be 1 over 81. Number 5, 5 to the negative 1 power plus 4 to the negative 1 power. We would have to rewrite each of these first. So this would be 1 over 5 to the 1st plus 1 over 4 to the 1st, which is 1/5 plus 1/4. And if you actually wanted to perform that operation, you would need a common denominator. So multiply by 4, multiply by 5 to get a common denominator of 20. So you would get 4 over 20 plus 5 over 20. So this expression would simplify all the way down to 9 over 20. On number 6, you've got 2 options. We have x to the 5th over x to the negative 3rd. You can use quotient rule if you want to. And so remember, quotient rule says you can subtract the exponents. So this would be 5 minus negative 3. And when you subtract a negative, you're actually adding. So this would be x to the 8th when you simplify. Or another way of thinking about it, since x to the negative 3 has a negative exponent, you need to move it. It's in the denominator, so you would move it up to the numerator to make it positive. So this is the same thing as x to the 5th. And then I'm moving that x to the 3rd up to the numerator. And now, since I moved it, there's only a 1 left in the denominator. And so this would just be using the product rule, add the exponents, and you would get x to the 8th. So you can think about number 6 either way. You can think about it as the quotient rule or changing that negative exponent up to the numerator. All right, go ahead and pause the video and try these 6 problems. All right, y to the negative 7 is the same thing as 1 over y to the 7th. 7 to the negative 2 is the same thing as 1 over 7 squared, and if you simplified that, you'd get 1 over 49. 1 over x to the negative fifth would be x to the positive fifth. You would move x to the negative fifth up to the numerator. X to the negative first over x to the negative 8. You can use quotient rule, so you could subtract. Negative 1 minus negative 8, you would add, and you would get x to the 7th. Or you could move both of them. X to the negative 1 would have to move to the denominator, and x to the negative 8 would move to the numerator. So you would get x to the 8th over x to the 1st. And you could subtract the exponents, and you would get x to the 7th. On the next one, 24 over 12 is 2, so you would get 2. And then x to the 6th over x to the negative 8. So it would be 6 minus negative 8. So it would be x to the 14th. So you would get 2x to the 14th. 2x to the 4th, y to the negative 4th over 8x to the 7th, y to the 3rd. Again, we can reduce the coefficients out in front. 2 over 8 is the same thing as 1/4 when I reduce. X to the 4th over x to the 7th. If I simplified those, I would have 7 x's in the denominator and 4 x's in the numerator. And so if I simplified them, I'd have 3 x's left over in the denominator, so that would be x to the 3rd. And then y to the negative 4th over y to the 3rd. So y to the negative 4th minus 3. This would be y to the negative 7th, so I would have 7 y's in the denominator after I simplified. So that would be 1 over x to the 3rd, y to the 7th. And then we would have x to the 4th minus 7, so that would also be x to the negative 3. So notice, both x to the negative 3 and y to the negative 7th, if we used quotient rule to make those exponents positive, you'd move them down to the denominator. All right, go ahead and pause the video and try these 4 problems. All right, x to the 9th times x to the negative 7th. The rule for product rule is you can add the exponents. So 9 plus negative 7 would be 2. So it would be x to the 2nd power. F to the negative 3 times f to the 2 times f to the negative 3. The rule is you can add the exponents. So negative 3 plus 2 plus negative 3. This would be f to the negative 4, which would be 1 over f if you rewrote it without the negative exponent. 2x to the 3rd, y to the negative 3 raised to the negative 2 power. So every term on the inside is going to be raised to the negative 2 power. So this would be 2 to the negative 2. And then power rule says multiply the exponents. So it would be x to the negative 6, and then it would be y to the positive 6. The 2 terms with negative exponents should move down to the denominator. Y to the 6 can stay. So we have y to the 6th over 2 squared, and then x to the 6th. So this would be y to the 6th over 4 x to the 6th. Same thing on the next one. We've got a lot of terms, so all of them will get negative 2 as an exponent. So everybody in the numerator gets negative 2 as an exponent, and everybody in the denominator gets negative 2 as an exponent. So if I rewrote this, this would be negative 2 to the negative 2 power. Multiply the exponents. So a to the negative 6th, b to the negative 4th, c to the 0. All over 3 to the negative 2 power, a to the negative 4th power, b to the negative 6th power, c to the negative 2 power. And now I'm going to simplify this. Negative 2 to the negative 2 power is going to have to go down to the denominator. 3 to the negative 2 power is going to go up to the numerator. So I have 3 squared over negative 2 squared. And now let's deal with our a's. A to the negative 6th over a to the negative 4. I'm going to use quotient rule, so it would be negative 6 minus negative 4. And so if I simplified that, I'd get a to the negative 2. So I'm going to put a squared in the denominator to deal with the a to the negative 2. Now let's deal with the b's. B to the negative 4 over b to the negative 6. So it'd be b, and then you could subtract the exponents. And so negative 4 minus negative 6 would be b squared. So since that's positive, b squared just gets to stay up in the numerator. And then we'll deal with the c's. So c to the 0 over c to the negative 14th. So c 0 minus negative 14th. That'd be c to the 14th. So c to the 14th will be up in the numerator. And now if I simplify the coefficients, 3 squared is 9. So I get 9b squared c to the 4th over negative 2 squared is negative 2 times negative 2. So we get 4 and then a squared. So that final expression will simplify down to 9b squared c to the 4th over 4a squared. Your homework is